Okay, let's go. Let's continue the review. So we were at number, I think, 5C. And the question was as follows: y is equal to sine of 2x minus 1 cubed plus cos cubed of 2x minus 1. Okay, so we have to find, of course, y prime. Okay, so here's a question. So y prime. So the derivative of sine here is cosine of 2x minus 1 cubed times the derivative of 2x minus 1 cubed, which is 3 times 2x minus 1 squared, times the derivative of 2x, which is 2. Then plus here 3 times cos squared, times the derivative of cos, which is negative sine, and times the derivative of 2x minus 1, which is 2. This is my answer. Is that okay? Questions? Okay, let's go. It's D. So y is equal to sine of x to the power of ln of x again. What's y prime? So what do we do here? We're going to do logarithmic differentiation. So I'm going to put ln on each side. So y equals sine x to the power of ln x, and I'm going to put ln on each side. So ln y, and bringing ln x in front, ln x, ln of sine x, and now I'm going to derive both sides. Here I'm going to have a chain rule, so 1 over y times y prime, and then this is a product rule, so 1 over x times ln of sine x plus ln x times the derivative of ln of sine x, which is 1 over sine x times cos x.
So someone is waiting in the waiting room.
Excuse me?
Someone is waiting for you in the waiting room.
Thank you. Thank you. I didn't see. Okay, is that okay? So y prime, I'm going to isolate, is equal to y, which is this. So sine x to the power of ln x times all this, which is ln of sine x over x plus ln x times cos over sine, which is cotangent of x. Okay, any questions? Okay, E. This is the last one, the last question on derivatives, evaluating derivatives. So E, y, that's an easy one. E to the power of the square root of x2 plus 3. So y prime. So again, of course, the question is find y prime here. So this is a regular chain rule. Y prime is E stays to the power of x2 plus 3 times the derivative of the exponent, which is 1 over 2 times the root of x2 plus 3 times the derivative of the inside, which is 2x. And that's my answer. Okay, which we could simplify. You don't have to, but let's do it. Might as well, because there's things we could cross out here. The 2 and the 2 are out. And so I have on top x e to the root x2 plus 3 over the root x2 plus 3. That's my answer. Okay, any questions? Easy stuff. Let's move on. Number 6. So find an equation of the tangent line to the curve y is equal to 1 plus e to the negative x power 4 at x equals 0. Okay, so find the tangent at this point. So first thing we need is the derivative. So y prime is 4 times 1 plus e to the minus x power 3 times the derivative of the inside, which is e to the negative x times minus 1. Okay, at x equals 0, we get what? So y prime of 0, the derivative of 0. If you plug in 0 here, you get 1 plus 1 is 2, power 3 is 8, times 4 is 32. 32 times 1 times minus 1, so minus 32. This is the slope. And to find the y-intercept, I need a point. So what point do I have? So x is 0, and y will be y of 0, which is what? What's y of 0? You just plug in 0 into the function. 1 plus 1 is 2, plus power 4 is 16. So 0, 16, that's the y-intercept. So right away, y equals ax, or mx, 32x, plus the y-intercept, which we found right away as 16. And that's the correct answer. Okay, next. Number 7. So let f of x equals to x2 plus 1 over x plus 1 squared. So 2 questions here. I'll just move up a bit. So A, find f prime of x, so that's an easy quotient rule. And B, determine whether f has a local max or local min at x equals 1. Okay, that's the question. So f prime, so a f prime of x, so we're going to do the quotient rule here. 2x times the bottom minus the top times the derivative of the bottom, which is 2 times x plus 1, and all this divided by the bottom squared, which is x plus 1 to the power of 4. Okay, I could simplify things here a bit by factoring out a 2 and factoring out an x plus 1, an x plus 1. So it's equal to 2 times x plus 1. Is it written too small, or it's okay? It's okay? It's not blurry? Okay.
It's perfect.
Okay, so 2 times x plus 1 times, and here I will have x times x plus 1 minus, and here we'll have x2 plus 1. Over x plus 1 to the power of 4. So you see I could cross out an x plus 1. So I have 2 times, and inside the brackets, I have x2 minus x2 is out. And I have x minus 1 left. So 2 times x minus 1, and on the bottom I have x plus 1 cubed. So that's the first question they're asking us, is to find the first derivative of this function. Okay, now
That's
how do I,
good.
yes, yes?
What happened with the last like 2 multiplied by x plus 1?
The x, well, the 2 is still here. You mean the x plus 1?
Yeah, this like above.
Yeah, this one here, right?
Yeah, no, above that.
Oh,
Like
here,
the original one.
yeah.
Yeah, at the end. What happened with the 2 multiplied by
This one here,
yeah.
from here to here, where did it go?
Mm-hmm.
I factor it out, it's factored, right? If you multiply it inside here, if you multiply this here and this here, you'll get back to this,
Oh, okay, okay.
okay? Now, how do I decide at x equals 1 if I have a maximum or a minimum? Okay, so I know already that at x equals 1, the derivative is 0, right? If you plug in x equals 1 here, the slope is 0, so I know for sure that my function is either like this or like this, okay? Or, of course, or it could also be like this, okay? Maybe a flat thing like this. We'll talk about this later. But how do I decide if it's a max or a min? What do I do?
The
Test
second
like
derivative test.
I do the, I'm sorry, I heard something. The second derivative test. That's good. So I'm going to split this in 2, and I'm going to do the second derivative. I'm going to evaluate it right here. Okay, so I'm going to find the second derivative, plug in 1, and see if I get a positive or a negative. So let's go. F prime prime of x. So I'm going to write this now. Okay, so derivative of top is 2 times bottom x plus 1 cubed minus top 2 times x minus 1 times derivative of bottom, which is 3 times x plus 1 squared, and all this over the bottom squared, which is x plus 1 power 6. Okay, and now I'm going to simplify here. So I'm going to pull out again 2 and a 2, and I'm going to pull out in x plus 1 power 2. So 2 times x was plus 1 to the power of 2 times, so x plus 1 minus 3 times x minus 1. That's what I have. And on the bottom, x plus 1 power 6. And again, I could simplify the x plus 1 power 2 with this will become a 4. So equal, okay, so f prime prime of x is, so x minus 3x is negative 2x. So I have negative 2x plus 2, pull out a negative 2, so negative 4 times x minus 2. This is what you get if you simplify, and on the bottom I have x plus 1 power 4. Okay, so this is what I get for the second derivative. Any questions?
Yeah, sir, I had a question.
Go ahead.
Can you explain why we have to find the second derivative in order to figure out whether it's a local or min, instead of like just like using the first derivative?
Instead of what?
Instead of using the first derivative?
No, the first derivative doesn't tell you if it's a max or a min.
Okay.
The first derivative just tells you that there's a place where the slope is 0, like the picture I sent you, I just wrote here. Here, here, or here. These are places where the slope is 0, okay? I still don't know if it's a maximum like here or a minimum like here. This you still don't know. You understand? To do that, we need to find the second derivative and see if it's concave down or concave up.
Okay.
Okay, so I'm going to plug in 1 inside here. So f prime prime of 1, and I'm going to see what do I get. So if you plug in 1 here, I get -4 times -1 is 4, and 4 over 2 power 4 is 16. 4 over 16 is a quarter, and that's positive. So since it's positive, I'm like this, so I have a minimum. So it's a local minimum. That's it, that's all. Okay, number 8. So given, so the curve x2 minus xy plus y2 equals 9. So A, show that y prime is equal to y minus 2x over 2y minus x, and B, find the coordinates of both points on the curve where the tangent line is horizontal. Okay, so first thing we'll do is we'll find the derivative using implicit differentiation. So the derivative of x2 is 2x minus, how do we derive xy?
Product rule.
minus y.
Product rule. So don't forget, there's a lot of little things to be careful here. First of all, we put the brackets, and then the product rule. So 1 times y plus x times y prime, right? Don't forget. Plus the derivative of y squared is 2y times y prime, and the derivative of 9, of course, is 0. That's it. So now I just need to isolate y prime, and if everything goes well, I should get this expression here. So 2x minus y minus xy prime plus 2y y prime equals 0. Okay, so I will send these guys, because they have no y prime, I'll send them on the other side. And these two here, I'll just factor out a y prime. So y prime times 2y minus x equals, and this on the other side, I get y minus 2x. And so y prime is y minus 2x over 2y minus x. That's my answer. I just showed proof, done. Okay. Questions? Okay, now they're asking you to find the coordinates of both points where the tangent line is horizontal. In other words, when what? B, so tangent is horizontal when what?
The derivative is equal to 0.
Exactly. So when y prime is equal to 0. Thank you for answering. And so, in other words, we want this expression to be 0. So y minus 2x over 2y minus x must be 0. Okay. And of course, the denominator cannot be 0, so the numerator has to be 0. So basically, we want y to be equals to 2x. Okay, so y equals to 2x. We go back to our relation on top here. x2 minus xy plus y2 equals 9. And I'm going to replace every y by 2x. Okay, so let me just write it down here. x2 minus xy plus y2 equals 9. So this means that x2 minus x times y, which is 2x, plus y, which is 2x squared, is equal to 9. And that means that x2 plus 4x2 is 5 minus 2 is 3x2. So 3x2 is equal to 9. And so x is equal to plus or minus the square root of 3. Okay, and since y is equal to 2x, I could find the y for each one. And so I could get right away my 2 points. So when x is root 3 and when x is minus root 3, so the y will be 2 times that. So 2 root 3, and here will be negative 2 root 3. These are my 2 points. Are there any questions? Here goes. Oops. So question 9. Find the absolute extrema, means maximum and minimum, of, so f of x is equal to x power 1/3 minus x power 2/3, okay, on the interval -1, 1. So let's, the question is finding the maximum and minimum of this function over the interval -1, 1. So the first thing we do, of course, is we see if there are any critical numbers, okay? So basically numbers where the function is either has a derivative of 0 or is not differentiable, okay? So it's clearly continuous between -1 and 1 because there is no restriction here on the x. Okay, so I'm gonna write this down. F is continuous on -1, 1. Okay, therefore, it attains or reaches a maximum and minimum value. This is from the extreme value theorem, okay? That's what it tells me. So let's find the critical numbers. Basically, when f prime of x is equal to 0 or when f prime of x does not exist. Okay, so either I have a situation like this, okay, or of course like this, or the derivative doesn't exist, so maybe I have a situation like this, okay, or like this. That also could be a situation where we have a max and a min, even though it's not differentiable, but it's still continuous, so it attains its max and min. Okay, you with me? From the extreme value theorem. Okay, so let's find the derivative. That's the first thing we need to do. So f prime of x is equal to, so if I derive this, I get 1/3 x to the negative 2/3 minus 2/3 x to the negative 1/3. All right. So let's simplify this a bit. So basically I could pull out 1/3 times, so 1 over x to the 2/3 minus 2 over x to the 1/3. Okay, remember, if you have a negative exponent, it means you could shoot it downstairs. Same here, it goes downstairs. Okay, are you with me? Am I going too fast? Okay, so I need, I'm minusing two fractions, so I'm going to find the common denominator by multiplying top and bottom here by x to the 1/3. So 1 over x to the 2/3 minus, so I multiply the top by x to the 1/3 and the bottom as well. X to the 1/3 times x to the 1/3 is x to the 2/3. Okay, and so I could extract an x to the 2/3 outside. So 1 over 3x to the 2/3 times, and inside I have 1 minus 2x to the 1/3. So this is my derivative. Okay, simplified. Any questions?
Do we have to simplify?
In this case, yes, because that's going to help you to find your critical numbers, right? So my critical numbers is when the derivative is 0, basically when this is 0. And as you see, there's a denominator. So when x equals 0, the derivative doesn't exist because you cannot divide by 0. You understand?
Yeah.
Okay, so I'm going to write down right away here. Just move up a bit. So the critical numbers is when obviously x is 0 and when 1 minus 2x to the 1/3 equals 0. Okay, so this is 1 equals to 2x to the 1/3. So this means 1/2 is x to the 1/3. If you power 3 both sides, you get x equals 1 over 8. Critical numbers, 1 over 8, the derivative is 0, the slope is 0. X equals 0, the derivative does not exist. What do we do now? We find the value of the function at our endpoints and at our critical values. There you go. Okay, so just a reminder, my function was x to the 1/3 minus x to the 2/3. And so if I plug in -1 here, I get -1 minus 1, I get -2. If you plug in 0, you get 0. If you plug in 1 over 8, I get 1/2 minus 1/4, I get 1/4. And if you plug in 1, you get 1 minus 1, you get 0. So as you see, this is my maximum value, and this is my minimum value. Okay, so I reach my minimum at my endpoint -1, and I reach a maximum at 1 over 8. And if I were to represent this on a graph, I'll try maybe a small graph here, just to get an idea, get a feel for it. So at -1, -1, -2, 1, 1. So at -1, it's worth -2 right here. At 0, it's 0. At 1, it's 0. And at 1/8, it's 1/4, so right here. So my function looks like this on the interval. Okay, so as you see clearly, here's my max, and here's my min.